Peripheral cables, minus USB 2. The Universal Standard, a deep dive into USB 2 high speed. In the late 1990s, the computing world was a chaotic landscape of specialized ports. If you wanted to connect a mouse, you used a PS2 port. For a printer, you needed a massive parallel port. And for external drives, you often struggled with SCSI connectors. The Universal Serial Bus, or USB, was designed to replace this legacy mess with a single, hot-swappable, and self-configuring interface. While USB 1.1 started the revolution, it was the release of USB 2.0 in the year 2000 that truly changed everything. Often marketed as high-speed USB, this version provided the bandwidth and reliability necessary to turn the computer into a true multimedia hub. The architecture of the interface. To understand USB 2.0, we must first look at its physical and electrical construction. Unlike the complex parallel cables of the past that sent data across dozens of wires at once, USB is a serial bus, meaning it sends data one bit at a time over a very simple four-wire connection. Inside a standard USB 2.0 cable, you will find four primary lines. Two of these are dedicated to power: the VCC line, which carries 5 volts of electricity, and the ground line. The other two are the data minus and data plus lines. These two wires form what is known as a differential pair. Instead of sending a signal down one wire and hoping it doesn't get corrupted by noise, USB 2.0 sends the signal down both wires simultaneously, but with opposite voltages. The receiving device looks at the difference between the two wires to determine the data. This clever engineering trick allows USB 2.0 to maintain high speeds even in environments with significant electrical interference. Bandwidth and data transfer rates. The defining characteristic of USB 2.0 was its massive jump in speed. The original USB standards were painfully slow, topping out at 12 megabits per second. USB 2.0 introduced the high-speed specification, which theoretically supports up to 480 megabits per second. However, it is important for a technician to understand the difference between theoretical speed and real-world throughput. Because USB 2.0 is a half-duplex technology, it can only talk in one direction at a time, much like a walkie-talkie. Furthermore, the protocol has a significant amount of overhead, meaning a portion of that bandwidth is used just for the computer and the device to manage their conversation. In practice, most users see actual data transfer speeds of around 30 to 40 megabytes per second. While this seems slow by modern standards, in the year 2000, it was fast enough to allow for the first generation of high-speed external hard drives, webcams, and portable music players. Power delivery and the 5-volt standard. One of the greatest innovations of USB was its ability to provide power and data over the same cable. This eliminated the need for wall-wart power adapters for small peripherals like keyboards and mice. Under the USB 2.0 specification, a standard host port is required to provide up to 500 milliamperes of current at 5 volts. This power limit created a unique set of challenges for hardware engineers. For example, many early external hard drives required more than 500 milliamps to spin up their internal motors. To solve this, you might remember seeing Y-shaped USB cables that plugged into two separate ports on the computer, one for data and power, and the second just to steal extra power from a neighbor port. This limitation eventually led to the development of dedicated USB charging specifications, which allowed for higher amperage. But for the vast majority of its life, USB 2.0 was defined by that strict 500 milliamp ceiling. The family of connectors. USB 2.0 is famous for its wide variety of connector shapes, each designed for a specific type of device. The Type A connector is the rectangular plug we are all familiar with. This is the host connector found on computers and hubs. It was designed to be extremely durable, intended to be plugged and unplugged thousands of times without failing. The Type-B connector is the square-shaped plug often found on the back of printers and large external hard drives. The physical difference between Type-A and Type-B was an intentional safety feature. It prevented users from accidentally plugging two computers into each other, which could cause an electrical short circuit. As mobile devices became popular, the industry needed smaller plugs. This led to the Mini-B connector, which was common on early digital cameras and MP3 players. Eventually, the even smaller and more durable Micro-B connector was developed. Micro-B became the global standard for nearly every smartphone and tablet for over a decade. Micro-USB also introduced a fifth pin, known as the ID pin, which enabled a technology called USB on the go or OTG. This allowed a mobile phone to act as a host, meaning you could plug a keyboard or a thumb drive directly into your phone using a simple adapter. The host-centric relationship. A key technical detail of USB 2.0 is that it is a host controller-based system. This means that the computer is always the boss of the connection. Peripherals like your mouse or keyboard cannot speak until the computer asks them if they have anything to say. This process is called polling. Every few milliseconds, the computer's USB controller sends a message down the bus asking, "Does the mouse have any new movement?" If the mouse has moved, it sends the data back. If not, it stays silent. This host-centric design is one reason why connecting too many high-bandwidth devices to a single USB 2.0 hub can cause performance issues. If the host controller is too busy polling a web camera, it might delay polling your keyboard, resulting in input lag. Compatibility and the modern legacy. Perhaps the most impressive feat of USB 2.0 is its backward compatibility. When USB 3.0 was released years later, the engineers ensured that the old 2.0 devices would still work in the new blue ports. Even today, on the most advanced modern computers with USB-C ports, the underlying USB 2.0 signals are still there. Many modern keyboards and mice still use the USB 2.0 protocol because they simply don't need the extreme speeds of newer versions. For a technician, USB 2.0 represents the era where the plug-and-play dream finally became a reality. It taught us that a single, standardized interface could handle everything from a simple light-up toy to a complex digital audio workstation. While it has been surpassed in speed by USB-C and Thunderbolt, the four-wire differential pair of USB 2.0 remains one of the most successful and widely deployed pieces of technology in human history.